Okay, so let us continue with chapter 10 today. Today we are going to look at superpositions of wave 10.2. So we are done with progressive wave, a wave that's moving. Today we are going to look at what happens when two moving waves they are overlapping with each other. Okay, so let's see. Now initially you have a wave. Okay, initially you have a wave coming from left hand side, right? So this is a wave, and then another wave coming from the right hand side. Right, so when these two waves they are overlapping with each other, what is going to happen? So the point they're overlapping, they add up. Okay, every point, the displacements along these two waves, they are adding up to each other when they are moving. So at one point, okay, at one point you'll get a wave that seems like that is not moving, and that's what we call standing wave. Okay, the wave that seems like it is static, it is not moving, so it is oscillating at its maximum amplitude. So when you come to this case, what is the equations that we're going to have? Okay, now we have a new equations called y equals to a cos kx sine omega t. So this is the equations for standing wave, where the first part of the equations, if you remember, this is what we call amplitude equations. Okay, the amplitude equations, where we use it to show the amplitudes of the wave. Okay, the amplitudes of the particles to be more precise. So this is the amplitude of the particles, right? So the amplitudes of the particles, that is the equation. So when it comes to these equations, there's one more thing that you need to understand. Okay, you need to know. Now, if you have a progressive wave, the equations is just y equals to, now I'm going to use small letter a here. Okay, because small letter a and capital letter A, they are slightly different. So when you have progressive wave, the equation is just a sine omega t. Now your wave is going to the right, so negative sine kx, and then when it's going to the left, so y is equals to a sine omega t plus kx. Now you have a here, you have a in the equations of progressive wave, and you also have a in the equations for standing wave. So their relationship is capital letter A is equals to 2 small letter a. And this small letter a, it represents another types of amplitude, in which we call this is the amplitude of, okay, amplitude of what? Amplitudes of progressive wave. Okay, progressive wave. So we have two different types of amplitude here, and there's one more amplitude that we have, which is a capital letter A. Small letter a is the amplitudes of progressive wave. Capital letter A is the amplitude, okay, amplitude of standing wave. Okay, amplitude of standing wave. And when you have equations a cos kx, that is the amplitude of particles. So you have three different types of amplitude for three different objects. First one is for standing wave, which is capital letter A, and then small letter a, which is for progressive wave, and for particles, which is a cos kx. So you need to understand these equations very well in order to solve the questions. Okay, because sometimes questions will be asking for different types of amplitude. Okay, it could be progressive wave, it could be stationary wave, and it could be particles. So you need to know which one to use, okay, which information to calculate. So basically that's it. Okay, that's all we have in 10.2. So when these two waves, they're overlapping with each other, you get a standing wave where the maximum value, okay, the maximum values of the wave, we call it antinode. Okay, the maximum amplitude, this is what we call antinode. And then the minimum amplitude, which is a zero here, the place where their total amplitude is equal to zero, this is what we call node. Okay, it undergoes total cancellations. So to make it easier, I'm going to show you the graph, the one that we have in the lecture. Okay, so this is the diagrams that we have in lecture. So it's very important for you to know when will you have a antinode and when will you have a nodes in the diagram. So let's say if your wave start from amplitude, which is antinode, then the first node would occurs at lambda over 4. Okay, this is where you're going to experience, you're going to have a first node. So the first antinode you're going to have, of course, is when x equals to 0. And then the second antinode that you're going to have, which is here, okay, at here, which is lambda over 2, okay? It happens at lambda over 2 after it oscillates for half cycle. So you need to know all this value, okay, all the x distance in order to calculate the the positions of node and also the antinode. So for example, if you're given a graph like this one, all right, if you're given a graph like this one, and question asks you to state the position of first three node, okay, first three node. So this is one of the questions that can be asked in exam, okay, the positions of first three nodes. So where is nodes according to diagram? So the first node is located at lambda over 4, and then the second node is located at 3 over 4 lambda, and the third node is located at 5 over 4 lambda. And now what is their relationship? If you look at the value, you will see that nodes happen at every half wavelength. Okay, it happens at every half wavelength, which means if you are given the first value, or if you manage to calculate to determine the first value, then you can calculate the positions of second node and third node by adding half lambda to the first value, to the previous value. Okay, so let's say if you have made some calculations, you obtain the value lambda over 4, that is the positions of first node. And then questions ask you to state the position of first 3 nodes, for example. Then how are you going to find out what is the value, what is the position for second node? You plus lambda, you add lambda over 2 into the first value, into the lambda over 4. Okay, then you obtain 3 over 4 lambda. And then you add another half lambda to 3 over 4 lambda, you obtain 5 over 4 lambda. So it keeps going on. Depends on how many values that questions want. Okay, how many values the questions are asking for. Sometimes they might ask for the position of first 5 nodes. Okay, I think that is one of the past year question where question asks you to state the position of first 5 nodes. All right, and sometimes questions will state like this. You have to be careful. It asks you to state the positions, okay, the position of first 2 antinode, for example. All right, first 2 antinode, excluded 0. It will state that, okay, exclude 0. So you don't take the value 0 here. So the first antinode would be located at lambda over 2, and the second antinode will be located at lambda. So that is the values that you need to state. All right, you cannot include 0, because sometimes questions will state that, okay, you determine the position, okay, except when x equals to 0, okay, except for when x equals to 0. So you need to know where is node and where is antinode. That is very important. Okay, so we have nodes at a 0, okay, when y is equals to 0, this is our node. And for antinode, okay, for antinodes, we have the maximum value here, okay, which is located at the amplitude. So that is our antinode. You need to know the position in order to calculate, okay, in order to calculate the value, the positions of every single nodes and antinodes. And meanwhile, okay, the shortest distance between a consecutive node and antinode, okay, if you look at this one, the position, the distance between a node and an antinode is lambda over 4. Okay, it's lambda over 4. So this is also a thing that you need to know, right? This is also things that you need to know. So the distance between two consecutive, okay, dua nodes yang berikutan, yang berturutan, two consecutive node, okay, let's say node and node, the shortest distance between them is lambda over 2, okay, lambda over 2. Whereas for a distance between two consecutive antinode, it is also lambda over 2, but the distance for two consecutive node and antinode is just lambda over 4. So this is the information that you need to know. All right. So basically, we are done with the summaries for 10.2. We are going to look at the formations of standing wave, how to use standing wave equations, which is y equals to a cos kx and sine omega t. Where does it come from? Which come from two progressive wave. Okay, it's coming from two progressive wave. So by combining y equals to a sine omega t minus kx and y equals to a sine omega t plus kx, we obtain these equations called y equals to a cos kx sine omega t. So you need to know what is the general equations and what is the information that you can get from the equations. So now let's look at questions 1. Okay, let's look at questions 1. Questions 1, two harmonic waves, they are represented by the equations below, where y1 and y2 and x, they are in centimeter. Okay, you have a 1 in cm and t in second. Okay, you have a cm and also you have second. Write an expression for the new wave when both waves, they are superimposed. Superimposed means they are overlapping with each other. So when these two waves, they are overlapping with each other, you are going to obtain a standing wave. So this one, it gives you, okay, it gives you a standing wave. So standing wave, another name is called stationary wave, which means a wave that seems like it is not moving. Okay, the wave that is not moving. So write an expression. So you need to know what is the general equations. So general equation for standing wave is y equals to a cos kx sine omega t. Now, we need the values of a, okay, we need the value for a, we need the values for k, we need the values for omega. Where can we get this value? First of all, let's go back to the equations given. You're given these two equations, and what is it? These two equations, they are equations of progressive wave, which the general equation is y equals to a, okay, I'm going to use small letter a here. So a sine omega t plus minus kx. This is the general equation for a progressive wave. So by comparison, okay, by comparisons, the information that you can get straight away is the omega and also k. So it doesn't matter which equations you're looking at, okay, they are going to have the same omega and same k. It doesn't matter whether you're looking at progressive wave or you're looking at stationary wave. They have same omega, they have same k. But the difference is just in terms of a, okay, because they are moving with same frequency and so on. Same frequency, same wavelength, but with different amplitude. So by comparisons, we have k equals to, okay, we have k equals to 2 pi, and then we have omega equals to pi. Then how about this a? So we know the relationship between progressive wave and stationary wave is that a is equals to 2 small letter a. Small letter a gives us 5. Okay, small letter a is equals to 5. Therefore, capital letter A is equals to 10. 10 what? 10 cm. Okay, because the question tells you your y1, y2, and x, they are all written in cm. So now that you have a, you have k, you have omega, okay, you can then get the equations for the new wave, which is y equals to 10 cos 2 pi x sine pi t. So this is the equation, okay? This is the answer, and this is how we form equations. So you try to identify the informations needed from progressive wave first. And then from there, we then form the new expression for stationary wave. Right? Okay, so let's see. Yeah. Okay, you got friends who is being quarantined. Okay, never mind. All right, now let us continue. Okay, let's continue with questions B. Questions B, determine the wavelength and the frequency. Isn't it very familiar with these two terms again? Omega and frequency. The wavelength, sorry, lambda and frequency. So, okay, lambda and frequency. If you remember, okay, how are you going to calculate it? Okay, so if you remember the things that I keep mentioning almost every hour, okay, lambda is coming from family, okay, omega, lambda, and frequency. So this is one family. The second family is, oh, sorry, I got a mistake here. It's not lambda, it's period. And then the second family is, okay, it contains a k and lambda. So this is a second family. So which means if you have one of the items in the family, okay, in the same family, then you'll be able to determine the other one. For instance, if you want to calculate the values for frequency, then you see whether you have the information for omega or for t. Well, now for these questions, we have the values of omega. So which means we will be able to determine the frequency of the stationary wave. And then, okay, if you want to determine lambda, you need k. So do you have a k? Yes, you do. Okay, so from the equations above, from the equations given, okay, wait, yeah, let me get a mouse first. All right. So from these equations given, okay, from the equations given, so we have omega and we have k already. Okay, straight away we can use it to calculate lambda and also frequency. So omega, okay, omega is equals to pi radian per second. Okay, and the relationship between omega and frequency is that omega equals to 2 pi f. So which means 2 pi f at the same time is equals to pi. So rearrange the equations, we then obtain pi, f is equals to, okay, pi and pi cancel out, f is equals to 0.5 hertz. So this is the answer of frequency. How about lambda? How about wavelength? So again, by comparisons, we obtain k equals to 2 pi. Okay, what is the unit? Well, you're given x in terms of cm. So k obviously is cm negative 1. Okay, cm negative 1. So k equals to 2 pi cm negative 1. And the relationship between k and lambda is that k equals to 2 pi over lambda, which is then equals to 2 pi. Rearrange equations, you have lambda equals to 1. And because your k is in terms of cm negative 1, so lambda would be in terms of cm. So this is the answer for questions B. So that is how you solve it. Okay, basically it's quite similar to how you solve the questions in a progressive wave. The only difference is in terms of the amplitude. When it comes to 10.2, you have 3 different amplitude here. Amplitude of progressive wave, amplitudes of stationary wave, and amplitude of particles. So you need to know the relationship between these 3 types of amplitude. That's it. That is what you have to know in 10.2. All right, so now I give you 1 minute, okay, 1 minute to go through the revisions, especially the amplitude, okay, the equations, and then to write down the answer for questions 1. All right, so now it's 2:18. I give 2 minutes, okay, 2 minutes for you to write it down. So let us move on to question number 2. So question number 2, now you got these questions, the questions I explained it to you just now. So a stationary wave is represented by the following equation. So you are given an equation, y equals to 15 cos 0.5 pi x sine 5 pi t. So what should you do now? The first thing, the most important things that you should do is to compare with the general equations. So the general equation for standing wave or for the stationary wave is y equals to a cos kx sine omega t. So this is the general equations. Okay. So by comparison, straight away you can obtain the informations for what? The informations for A. Okay, now your A is 15 in terms of cm, and then your K is equals to 0.5 pi cm negative 1, and then your omega is equals to 5 pi radian per second. Okay, 5 pi radian per second. Now, how are we going to calculate the three smallest values of x that is correspondent to nodes? Okay, you want to find a value for nodes, and then you want to find the value for anti-nodes. So what should you do? Okay, what should you do, and how should you calculate it? Okay, so if you want to find the positions of node, okay, then we are going to use the equations for particles. Okay, because if you look at the diagram just now, okay, if you look at the diagrams that I showed you just now, basically, okay, we have a graph like this. This is just an example, okay? This is just an example. Sometimes the graph might not start from a maximum value. It depends on the questions, all right? It depends on the questions. So this is y, this is x. So if you look at this one, okay, if you look at this graph, what happens right here is that at positions node, okay, the displacement of the amplitude is equal to 0. All right, the displacement of the amplitude is equal to 0. So this is the equations that we're going to use. So we're going to use a cos kx to determine the positions of node, because it happens when your particle's vibration is equal to 0. Okay, and of course you can say a is also equal to 0, but that is no meaning. Okay, it has no meaning at all, because if you say a equals to 0, then what is the things that you're going to calculate? So to calculate the position, what are we going to do? We use a cos kx. Okay, we just want the value. Okay, we just want the value. We don't want to know whether it's positive or negative. So a cos kx, it is equals to 0 at nodes, because particle is not vibrating at nodes. Okay, at nodes, my particle is not vibrating. Therefore, okay, to determine the positions of node, we use the amplitude equations by equate to 0. Okay, because at node, as you can see in the diagram, the displacement y is equal to 0. So rearrange the equations then. Okay, next thing, we are going to rearrange the equation. So kx is then equals to cos negative 1, 0. Okay, so a, you move it to here, it becomes 0. So you're left with kx equals to cos negative 1, 0. Cos negative 1, 0, the value that it gave you is, okay, so kx is then equals to, okay, is then equals to 0. Okay, is then equals to 0. And of course, the following value would be pi, because we know the distance between two nodes is always lambda over 2, which is equals to pi, half lambda, okay, or half cycle, okay, half cycle. So pi, and then followed by 2 pi, followed by 3 pi, okay. So, of course, we have more value. So 0 is the values that we don't want. So we leave it first, okay, you don't do anything about it first. And now what should we do with k? So given k is equals to 0.5 lambda, okay, so 0.5 pi, sorry, 0.5 pi x is then equals to 0, pi, 2 pi, 3 pi, and so on. All right. So rearrange the equations. The values that you're going to get is then equals to, okay, x is now equals to, the first one is 0. Okay, the first one is 0. And then the second one, 0.5 pi divided by pi. Wait, yeah, 5 divided by 5. Oh, yeah, this is kx equals to m pi. Aha, I got the wrong value. It should be 1. Sorry, not 0. It should be 1. Right. Cos negative 0. Okay, cos negative 0, it gives you 100. Wait, let me use calculator. Cos negative 1, 0. So it's 90 degrees, sorry. So 90 degree is a pi over 2. So the first value would be pi over 2 here. Alright, saya ada salah kira di sini. So yeah, cos negative 0 give you pi over 2. So you know the next one, you need to add it by pi. Therefore, the following value would be 3 pi over 2. And then you have a 5 pi over 2. And if you want more, then of course you have more. But now the question is asking for 3 smallest value. Okay, 3 smallest value. So rearrange the equation, 0.5, you move it over to here. You are going to obtain 1, 3, and 5. Okay, 1, 3, and 5. So this one, I'm going to rewrite it first. Pi over 2, 3 pi over 2, and 5 pi over 2. So 0.5 pi x equals to pi over 2, 3 pi over 2, 5 pi over 2, and so on. Rearrange the equation. X is then equals to 1 cm, 3 cm, 5 cm, and so on. Okay, 1, 3, 5, and so on. So this is how you solve it. Okay, this is how you solve it. So I just make a mistake right here just now. Okay, saya cuma buat satu mistake sahaja dekat cos negative 1. So cos negative 1, 0. It gives you 90 degree, which is pi over 2 radian. Okay, it gives you 90 degree, which is pi over 2 radian. So first value is pi over 2 radian, then followed by 3 pi over 2, followed by 5 pi over 2 radian. All right, because why? Because according to the diagram given, the distance between two nodes is always pi. Okay, the distance between two consecutive nodes, between neighboring nodes, is always equivalent to pi, half cycle. So you have pi over 2. So what are you going to do? You plus pi, and then you just keep adding pi. All right. If question is asking for the fourth smallest value, then what you have to do, you just keep adding pi to the previous value. So the following one will be 7 pi over 2, 9 pi over 2, and so on. So k given is 0.5 pi. So now I have a 0.5 pi here. So I sub it into the equations for k. So k is then equals to 0.5 pi. Rearrange the equation. So x equal to 1 cm, 3 cm, 5 cm. So this is the smallest value, okay, 3 smallest value. So basically you just do the same thing for NT nodes, okay. So NT nodes, we are going to use the same equation, a cos kx, but now this equation, this value would be equals to the amplitude of the standing wave, okay. So now the positions of particles is equals to the amplitude of your standing wave. This is your A, okay. So NT node happens at when amplitude of the particle is equals to the amplitude of stationary wave. Rearrange the equations. We then have cos kx equals to 1. Kx is then equals to, okay, so now you have a cos negative 1. Now you got a 0. Okay, now you got a 0 here. So kx equals to 0. Of course, that is the first value. So following value would be pi, and then 2 pi, and then 3 pi, and so on. Why? Now let's go back to the diagram. So this is the positions of NT node. Okay, NT node, NT node, NT node, NT node. And we see that, we know that the distance between them once again is lambda over 2 or 180 degree, which is pi. Okay, so either pi or lambda over 2. So same as your nodes. Okay, so the distance between two NT nodes is also equals to pi. That's why when first value you obtain 0, the following NT node would happens at pi. And then after that, you add another pi, you got 2 pi, you add another pi, you got 3 pi. So you just keep adding pi. Depends on how many values the question is asking for. So again, kx, what do we have? We have kx equals to 0.5. So 0.5 pi x equals to 0, pi, 2 pi, 3 pi, and so on. X is then equals to 0, and then 2 cm, 4 cm, 6 cm, and so on. So answer, okay, answer, because question is asking for 3 smallest value exclude 0. Okay, exclude 0. So the final answer will be 2 cm, 4 cm, and 6 cm. So make sure you read the questions carefully. Sometimes if the question didn't say anything about 0 position, then you can just leave it. Okay, but now for this questions say they don't want 0. So what you have to do, you have to show all of them. All right, you have to show all 3 value without 0. All right, so is that clear for this question? Untuk soalan ini jelas tak?
Jelas.
Okay, so bagus. Okay, yang penting kamu tahu macam mana nak cari posisi dia. Kenapa kita tambah pi? Kenapa kita tambah lambda over 2? It's all because of the diagram. So first things you have to know is the diagram. Where is node? Where is antinode? So you look at the position. If questions give you the value in terms of lambda, then for every nodes, you just keep adding lambda over 2, lambda over 2, lambda over 2. But now this one, okay, the ways that we calculate it, because we're using pi over 2, we are using angles, we are using radian. Therefore, okay, I keep adding pi radian into the value. Okay, I keep adding pi radians into the value. So that is how we solve it. Okay, that is how we determine the position. You look at the information given. Given wavelength, you keep adding lambda over 2. Given in terms of angular displacement, which is the radian, then you keep adding pi radian. Okay, because according to the diagram, that is the distance between 2 nodes. That is the distance between 2 antinodes. So this one is slightly more complicated. I give you 5 minutes. Make sure to write it down, including the diagram. Okay, sketch diagram supaya Anda nampak. Kenapa saya tambah lambda? Kenapa saya tambah pi? Okay, kenapa saya buat 3 kali pi? Kenapa saya buat 2 kali pi dan sebagainya. So catat diagram ini. Okay, catat diagram ini. Okay, so if there's something that you don't understand, make sure to ask, yeah? Because this one is a bit abstract. You need a bit of imagination to see what is going on. Okay, if you're done, you may try questions B. Okay, you may try questions B. So questions B is just very simple. It's asking for the amplitude of a particle. So you look at the questions carefully. It's asking for amplitude of particle. So which part of the equation should you use? Which A should you calculate? Now think about that. Right, let's look at questions B. So questions B question is asking for amplitude of particles. Therefore, we're going to use amplitude equations for particles. So amplitude of particles is equals to A cos kx. So this is the value. Okay, this is the things that we're going to calculate. So A cos kx, now we are given x equals to 0.5 cm, then how about A? So if you look at the equation, just now we say A is equals to 15 cm. Okay, so given A is equals to 15 cm, so when x equals to 0.5 cm, when x equals to 0.5, so we have value, okay, I'm just going to write amplitude here to make it easier. Okay, because it doesn't have a symbol, what you can say is just an amplitude of particle, or you can just write down a full full terms called amplitude. So amplitude is equals to 15, okay, 15 cos k, the values that we have just now is 0.5 pi, right? C, yeah. Okay, so k is equals to 0.5 pi, so 0.5 pi here, and then x is equals to 5 cm, 0.5 cm, so 0.5. So key into the calculator, and then just press enter, then you get the final answer. So 10.6 cm here. All right, so make sure your calculator is in mode radian. Okay, make sure your calculator is in mode radians, because now we are looking at the values in terms of radian. So the second value, when x equals to 1.1 cm, the amplitude is equals to 15 once again, and then cos 0.5 pi times 1.1. So you will obtain a negative 2.35 cm. Okay, negative 2.35 cm. And then when your x is equals to 2.2 cm, amplitude is then equals to 15 cos 0.5 pi and again 2.2. So the final answer is negative 14.3 cm. Okay, so that is the answer for questions V. Very simple. Okay, all you have to know is now which amplitude are you going to use. So since questions talk about amplitude of a particles, mean it's asking for the values of A cos kx. Okay, because that is the value, that is the equations that we use to calculate the amplitude of a particles. So if question is asking for amplitude of the wave, of the stationary wave, then you just look at the capital letter A. If the question is asking for the amplitude of the wave before they superimpose, which means it's asking for amplitudes of a progressive wave, then you use small letter A. Okay, so that is questions B. So 1 minute for you to write it down, then we will move on to questions number 3. So if you're done, you may try questions number 3 first. Okay, questions number 3 is very similar to questions 2. Oh, actually, I think it's much simpler than questions 2. All right, next. So transverse wave travels along a stretched spring at a speed 80 meter per second. So you have a speed which is v and frequency 200 hertz. Stationary waves are produced on the string. Okay, determine the distance between two adjacent nodes and then a node and antinode nearest to it. Now, questions 8. For two adjacent nodes, okay, distant, okay, to be more precise, it should be distant between two adjacent nodes. So based on the diagrams that we've seen just now, the distance between two nodes is lambda over 2, right? So which means now we need the values of lambda. We need this wavelength. So can we calculate wavelength? Obviously we can. Because we are given v, we are given f, and we know wave speed, v is equals to f lambda. So rearrange equations, lambda is then equals to v over f, which is then equals to 80 over 200. Okay, so you have a 2 force, okay, it's 2 over 5. Okay, 2 over 5 cm. So now what are you going to do? You sub it into the equations. Okay, you sub it into the equations, then you should be able to obtain the value. So lambda is then equals to 2 over 5 divided by 2. Okay, divided by 2, you then obtain 2 over 10, which is then equals to 0.2 meter. All right, 0.2 meter. So this is cm. Wait, yeah, 0.2. Am I right? It should be, oh, I make a mistake in the unit. It should be 2 over 5 meter. Right. So that is correct. Okay, that is correct. So distance between two adjacent nodes is equals to lambda over 2. So by looking at the questions, okay, so we are able to determine the values of lambda. So lambda equals to v over f, which is then equals to 2 over 5 meter. Okay, so you sub it into the equations, lambda over 2. From there, you then obtain 0.2 meter. So questions B, distance between a node and an antinode is equals to lambda over 4. Okay, it is equals to lambda over 4. Therefore, it is equals to 2 over 5 divided by 4, which is then equals to 0.1 meter. So that is how you solve it. Very simple. Okay, you just need to understand the diagram. Okay, need to understand the diagram. So 1 minute for you to write it down before we move on to exercise 3. Okay, exercise 3. So ini senang saja. Okay, yang susah punya soalan 2. The hardest question is questions number 2. Just make sure you understand how to obtain 3 smallest value, how to obtain a 4 smallest value, and so on. Okay. All right. So exercise 3. Exercise 3, sound intensity. Okay, sound intensity. So sound intensity, now you're looking at intensity. So the things that you have to know is just equations. Intensity is equals to power per unit area. Okay, power per unit area. So power, the equations, okay, the equations for power is E over T. So this is E over T, and then area can be calculated now. Because sound is traveling out in all directions, so the shape of the sound is a sphere. Okay, so the area for a sphere is 4 pi r squared. Okay, 4 pi r squared. Right. So E over T and 4 pi r squared. So E, the energy can then be calculated by using 1 over 2, oops. Okay, 1 over 2 Ka squared over T. All right, so the equations of energy is 1 over 2 Ka, because now you're looking at the energy in a particles. So a particle is oscillating. So when it is oscillating, you can calculate its total energy by using the equation from simple harmonic motion, which is K equals to half Ka squared. So based on this relationship, okay, we then conclude that I is proportional to A square, which is amplitude. Okay, this is amplitude square. Oh, excuse me. Okay, amplitude square. So this is from the power, okay, from the energy equations, where E is equals to half Ka squared. So the A right here, it represents amplitude. Okay, so from derivations, we then able to identify the relationship between amplitude and intensity, and also the relationship between amplitude and r squared. Why? How? So I is directly proportional or inversely proportional to r squared. Okay, directly proportional to 1 over r squared, also known as inversely proportional to r squared. Okay, so these equations, basically, if you plug it in, you derive it. Okay, you derive it, you obtain I equals to K 1 over 2 K amplitude square over 4 pi r squared. Okay, this is over T first. So which is equals to 1 over 2 K amplitude square divided by 4 pi r squared T. So this is the equation. So from here, we then obtain the relationship. I is directly proportional to amplitude square, and I is inversely proportional to r squared. Okay, so kamu plug in saja, derive, actually you will obtain this equation. But we seldom use these equations in calculations though. This equation is just for us to determine the relationship between I and amplitude of the particles, as well as the relationship between I and also R. So a loudspeaker radiates a sound wave uniformly in all directions. At a distance 5 meters from the intensity of the sound is a 0.35 watt per meter square. So this is our I. Okay, the intensity of the sound is 0.35 watt per meter square. Calculate the powers of the loudspeaker. So it's very simple. Why? Because you're given R, you're given I. Okay, so let us begin with the general equation A. So I equals to P over A. Now, question wants you to determine power, so we don't want to do anything about the power. We are given the values of I, and then we are given the values of R. Now, our equations don't have R, right? But then we also don't have area. Okay, equations I equals to P over A. This A represents area. We don't have the area, but we do have R, which means we can calculate area by using 4 pi r squared. So I is then equals to P over 4 pi r squared. So you have to make sure your R is in SI unit. Why? Because your intensity is given in SI unit. So 0.35 is then equals to P over 4 pi 5 squared. So P is equals to 110 watt. Okay, 110 watt. Now, questions B. Questions B asks you to calculate the sound intensity at a distance 7 meters from the source. So your given R equals to 7 meters. Okay, your given R equals to 7 meters. But then, okay, the question wants you to calculate intensity. Now you have the same source. Okay, you have the same source, which means, okay, they are going to have the same power. So power that you obtain from questions A is 110 watt, and this is the values that we're going to use in questions B. All right, because you are not changing the source, you're still using the same source. Therefore, it comes with the same power. So I is equals to P over 4 pi r squared. It is equals to 110 over 4 pi 7 squared, which is then equals to 0.18 watt per meter squared. So 0.18 Wm negative 2, that is the answer for question B. All right, that is how you solve it. So the key point in this question is whether you know that the power is to remain constant or not. Okay, if it is coming from the same source, if you're not changing anything, you're not doing anything about it. Okay, so I give you 1 minute to write it now before we proceed to questions 2. Okay. So questions, exercise 3 is just very short. After that, we will do exercise 5. Okay, I will skip exercise 4 first because I think that one need more time to explain it. So I'll keep it for next 2-hour sections. So after exercise 3, we will jump to exercise 5. Okay, now let's look at questions 2 first. A small source emits sound wave with a power output 80 watt. So you are given P equals to 80.0 watt. Questions 8. Find the intensity 3 meter from the source. So this is actually your R, your distance, your radius of the sound. So I is equals to 80 divided by 4 pi 3 squared, which is then equals to 0.707 Wm negative 2. Okay, so this is your questions 8. Now, questions B. At what distance would the intensity become 1/4 as much as it is at R equals to 3 meter? So initially, our I is 0.707. Now, what this question wants is it tells you now you have a second scenario. You are given a second case where now I2 is equals to 1/4 I1. Okay, so it's asking for the distance. So what are you going to do? Now you calculate I2. So I2 is then equals to 1/4 times 0.707. Okay, so it is equals to, okay, yeah, let me calculate first. 0.707 divided by 4. We have 0.1768. Okay, 0.1768. Now, before you reach final step, you keep the answer in 4 decimal places. All right, so this is I2. I2 now you have 1768, Wm negative 2. So by using I equals to P over 4 pi r squared, because question is asking for distance. So question is asking for R2, okay? So your I2, you use R2. So rearrange equations, what are you going to do? So 0.1768 is then equals to, now power is still the same, okay? Because it's coming from the same source. So P is equals to 80 divided by 4 pi r squared, okay? R2 squared. So this is the R for the second situation, second scenario. So rearrange equation, R is then equals to 6 cm, okay? Or we say 6 times 10 to the power of negative 2 meter. This is the value that we will get if we just calculate it straight away by using calculator. Okay, by using calculator. So it is equal to 0.06 meter. Okay. 6 cm or 6 meter, yeah? Class, you guys calculate got which value? I think it should be 6 meter, right? Let me check. Yeah, I think it should be 6 meter, not 6 cm. I think the final answer is wrong. All right, you guys check first. I think it should be 6 meter. All right, so I think this is wrong. Okay, now question C. Find the distance at which the sound intensity is 1.0 times 10 to the power of negative 8 watt per meter squared. So this question is basically very similar to the first question. All right, so question C, I is equals to P over A. So now I given 1 times 10 to the power of negative 8 equals to power is 8t divided by 4 pi r squared. Rearrange equation, r is then equals to 2.52 times 10 to the power of 4 meter. So this is the answer for question C. Okay, this is the answer for question C. Okay, so you guys try first. All right, so if you've got any questions, then you may ask. And for questions B, I think the answer should be 6 meter, bukan 6 cm. Okay, not 6 cm. 6 cm is too small and it doesn't make sense. So now we're going to take a short break. We're going to take a 5 minutes break. After that, we're going to continue with exercise 5. Okay, kita skip exercise 4 dulu sebab dia rumit sedikit. Kita pergi terus kepada exercise 5 dulu. Okay, exercise 4 kita tunggu hari Isnin yang kita ada 2 jam baru kita bincang. Okay, so 5 minutes break. Okay, so let us continue. Once we are done with these two questions, then that's all for today. Okay, so this Doppler effect. Doppler effect tells us what is the change in the observed frequency when there's a motion. Okay, either the source is moving or either the observer is moving. So the general equations that we can use, F naught is the observed frequency. The one with O is all about the observer. Okay, it is equals to, okay, it is equals to bracket V plus minus V observer over V, okay, either plus minus or minus plus, it's up to you, all right? So Vs. So some books, they use minus plus, so also can, both are correct. And then Fs. So Fs, now the subscript S is all about source. Okay, the subscript S, they are all about source. They are talking about source. Okay, wait. Okay, so they are both talking about source. So source means the things that generate sound, okay, the things that emit sound. So that is the source. So if you're looking at the one with O, okay, the one with O, it's all about observer. Okay, it's all about observer. So I have here observer. All right. So two quantity about observer and two quantity for the source. Then how about the other V? Now this V, the one without subscript, is simply the speed of sound. Okay, the speed of sound, which is a constant value. Now, it doesn't mean affected by the directions of the motion. Okay, it doesn't care. It doesn't care whether the object is moving, the observer is moving, or the source is moving. Okay, so now how do we determine the directions? If you remember, so let's say this is the observer. Okay, this is O, and then this is our source. Okay, this is our source. So we have observer, we have source. So what happens to the V? Now V, it doesn't matter whether your object, your observer is going to the left or going to the right, and then the source is going to the left or going to the right. The directions of this V, it's always from the source towards observer. Okay, that is the directions of V. So V, okay, V is always, okay, always from S to O, okay, from source to observer. Now, why is it important to know the direction? Because it tells us which sign conventions to use, okay, which sign conventions to use. If VO or VS, they are opposite to V, then we use positive sign in the equation. If VO and VS, they are towards the same direction, then we use negative sign. Okay, so let's say now I have a, this one. So if a V and VO or VS, they're in the same direction, then we use negative sign in equation. So if a V and VO or VS, they are in the opposite direction, then we use positive sign in our equation. Okay, in our equation. So that is how we determine the sign convention. And basically that is a summary for exercise 5. Very simple. Okay, you just look at what happens to the frequency, whether the frequency is getting higher or it's getting lower. Okay, now let's look at exercise 1. The siren of a police car at rest. Now, a police car is at rest, emits a sound, okay, at a frequency of 1,600 hertz. What frequency will you hear if you're at rest and the police car is now moving at a 25 meters per second? So what happens right here is that now this is you. Okay, this is you, and you are at rest. So you're at rest, what does it mean? Okay, you're at rest, it means VO is now equals to 0. Okay, and this is the police car with a siren. Now, why the questions give you the first statement? The police car at rest emits a frequency of 1,600 hertz. So this tells you the frequency of the source. So the original frequency, the frequency coming from source, you need to take the frequency when it is not moving. Okay, you cannot record the frequency when it is moving. So the reasons why it tells you now the police car is at rest is because it wants to tell you now your Fs is 1600 hertz. Okay. So if the frequency that is being observed by you is when object is moving, then that one we call it observed frequency. So that is a slight difference. Okay, there is a slight difference between observed frequency and frequency of the source. So this is a police car, and now, okay, it is acting as a source, the things that emit sound. So it is Vs equals to 25 meter per second. So what we do know, the directions of V is always from source to observer. So this is our V. And V is given 340 meter per second. It is a constant value. So usually will be given by the questions, all right? So the V is equal to 340 meter per second, the velocity of the sound. Now that we have all this information, let us simplify the equation first. So the general equations for Doppler effect, Fo is equals to V plus minus Vo over V plus minus Vs times Fs. Okay, now if you look at the diagram, okay, if you look at this diagram, according to the diagram, now I have a value that is equal to 0, which is my Vo. So which means I can simplify these equations by removing Vo from my equation because it is equal to 0. Therefore, okay, now I'm left with these equations. Fo equals to V over V plus minus Vs Fs. So given Fs is equals to 1600, and then V we have a 25, and then V we have 340, Vs we have 25, we can then determine Fo. But now the next questions would be, okay, my next questions would be, should I use positive or negative? So if you look at questions A, it now tells you the police car is moving towards you, which means now this Vs is going to the left-hand side. It's going towards you. Okay, this is towards you. So according to the diagram, now I have V and Vs, both of them, they are pointing toward the same direction. Therefore, the equations for questions A, F naught is equals to V over V. Now, same direction, we use minus sign. So V over V minus Vs, Fs. Okay, so you plug in the value, okay, 340 over 340 minus 25 times 1600. So Fo is then equals to 1726 times 98 hertz. So once you obtain the value, you can try to think of things in terms of common sense. Does it make sense or not? The original frequency is 1600. And now the sound is moving towards you. Towards you means it is getting closer. If it's getting closer, of course, the frequency will increase. The frequency observed by you should be greater, should be larger than the original frequency. So now you have 1600 hertz as the original frequency. You observe 1700 plus. Well, it makes sense. Means that you have the right answer in questions A. You have chosen the right sign convention to solve questions A. Okay, so that is how we solve it. Then how about questions B? Questions B, now you have a case that is away from you. So away from you means now the police car is moving toward opposite direction. Okay, so this is away from you. So if it is away from you, then for questions B, what am I going to do? Where should I write it? Okay, here. So questions B. So now my F naught is equals to V over V plus Vs. Because now my V and Vs, they are heading towards opposite direction. So Fs. So you plug in the value, eventually you obtain observed frequency. It is equals to 1490.4 hertz. Does it make sense? Yes, it is. Because now the sound is moving away from you. Then of course, some things that you observe, the frequency that you observe should be lower than the original frequency. So yes, this value, it does make sense. So you have chosen the right sign convention in your equations, okay, in your solution. So that is how we solve it. Okay, that is how we solve it. So now I give you a few minutes to write down the summary. Okay, to write out the summary and also the solution. Okay, and also the solution. And it will be better if you can, if you can sketch the diagram. Okay, you sketch this diagram so that you can see the relationship between every single variable. You can see how I simplify the equations and how I choose the sign conventions in my equations. Okay, how I determine the sign convention based on the diagram, based on the scenario given. So I give you four minutes. Okay, now it's 3:16. So I give you until 3:20 to write everything down. Okay, write down the summary and then write down the solutions, including the diagram, so that you can see it. Okay, so that you can see it. Okay, so now let us continue. Okay, so the last question now. This question is a bit tricky. Okay, this question is a bit tricky. So how are we going to solve this type of questions? So questions 2, a figure show O is a stationary observer. Okay, so now you have a stationary observer right here. So a source moves away from the observer and it moves towards the wall. So now you have a wall, you have an observer, and you have a source. So with a speed of 40 meters per second, the frequency of the source given is 1000 hertz, determines the wavelength in front and behind the source if there's no wall T. Okay, so first one, it asks you to determine the frequency behind and in front of the source if there's no wall. So it's very simple. All right, so you just assume there are two imaginary observer, I would say. Okay, imaginary observer. One is in front, one is behind. So you just calculate. Okay, you just calculate the frequency first. So initially, I have a source. Okay, so I assume there's nothing in front, there's nothing behind it. So let's assume now you want to calculate the wavelength in front of the source. Now your source is moving to the, okay, this is your Vs. Okay, your source is moving towards the wall. So imagine there is no wall now. Okay, and we want to calculate the wavelength. So what is the wavelength? So you just have to imagine there's an imaginary observer on the right-hand side. Okay, so your V is also going to the right. The sound is also going to the right. Vs is also going to the right. Therefore, your FO on the left-hand side. Okay, left-hand side is V equals to V over V minus Vs. Okay, because there's no observer. Observer is not moving. We assume there's an imaginary observer that is not moving. Okay, so this is an imaginary observer where VO equals to 0. So you just want to know what is the frequency on the right-hand side and what is the frequency on the left-hand side. Okay, so that is the things that we want. So this is your Fs. So plug in the values, you will get FO equals to 1133. Okay, 1133.35 hertz. So from here, you can then determine the wavelength on the left-hand side by using V equals to F lambda. So which V should you use then? Now, because you are looking at the sound wave, so this V should be the speed of sound, which is 340. Okay, so 340 is then equals to 1133.35 times lambda. Okay, times lambda. Rearrange equations, lambda is then equals to 0.3 meter on the right-hand side. Okay, now let's do it on the left-hand side, sorry. Now let's repeat the solution for the right-hand side. So now you have a source. Now you want to look at the sound wave. What happens to the wave on the right-hand side? So the directions of the sound, okay, your imaginary observer is on the right-hand side now. So the directions of the sound, your V is now going to the right. Okay, because your imaginary observer is on the right-hand side. But then, okay, your source is still going to the left, okay, because it moved towards the wall. So now your sound, okay, your source and your V speed of sound, they are heading towards opposite direction. Okay, they are heading towards opposite direction. So in this case, we are going to use F naught equals to V over V plus Vs, Fs, okay, which is then equals to 894.7 hertz. Okay, so by using V equals to F lambda again, we then obtain lambda equals to 0.38 meter. So does it make sense if you look at these two values, the one on the left-hand side and the one on the right-hand side? Yes, it is. Why? Because now my object is moving to the right-hand side. It compressed the wave on the left-hand side. Okay, it compresses it because it's moving towards the observer. Whereas for the right-hand side, the wave on the right-hand side, what happened right now is now you stretch the wave. Okay, so now you stretch it. Okay, you stretch the wave. Therefore, the wavelength is larger than the one on the left-hand side. So lambda on the right, larger than lambda on the left, means you got the right answer. You got the right idea in solving it. Okay, because this is a common sense. Okay, the one on the left is being compressed, the one on the right is being stretched. Therefore, lambda on the right definitely is greater than the lambda on the left-hand side. Okay, so the first thing that you have to know is the direction. Okay, the direction. So even though you are looking at the same source, okay, but the positions of the wave, okay, it shows you the directions will be different. The directions of the sound will be different. On the right means it's traveling to the right. If you're looking at the sound wave on the left, then the sound wave is traveling to the left. Of course, sound wave can travel ups and down as well. But in this question, it's just asking for the left and the right. Okay, for the left and the right. So now we have an answer for questions A. Okay, we have the solutions for questions A already. And then how about questions B? The apparent frequency heard by the observer from the source. Okay, so what is the frequency heard by the observer? Now, observer is on the right-hand side. Therefore, it's this case. Okay, you just use this case for questions B. So observer FO is equals to V over V plus Vs Fs. So it is equals to 894.7 Hertz. Right? Because now the observer, according to the question, is on the right-hand side. So questions A, I just asked you to put imaginary observer. Actually, there's nothing. Okay, you just look at what happens on the left and what happens on the right. But now questions B, you have a real observer now. Okay, you have a real observer right now. So how about question C? The apparent frequency heard by the observer caused by the reflections on the wall. So you want to look at the frequency that is being reflected by the wall. So what is going to happen right here now? So initially you have the wall right here. Okay, this is your wall. And then this is the source. So this is the first case, first scenario, first stage of the question. So this source, it emits sound wave, okay, and then it reached the wall. And when it reached the wall, what happened? Now the sound wave is being reflected. Okay, the sound wave is being reflected. So what we want right now is the values, is the frequency that is being observed by the wall. Okay, so what happens right here? Now actually we want what we calculate in here. Okay, the one on the left-hand side in the questions A. So this would be the answer for question C, part 1. So now we have an observer on the left-hand side. Now, observer doesn't mean that it must be a living thing. Wall can be observer as well, as long as it is the object, it is the item that received the sound wave. Okay, it doesn't mean that observer must be human. It doesn't mean that observer must be a living thing. All right. So in this case, our observer is wall. Wall is acting as observer. So we have an F naught equals to V over V minus Vs, Fs. Therefore, F naught equals to 1133.33 Hertz. Okay, 1133.33 Hertz. All right, just now should be 33, not 35. Okay, 1133.33 Hertz. Now, how about the second stage? Okay, so I'm going to call this stage 1 of the question. So stage 2, okay, so what should we do in stage 2? So stage 2, now you still have the wall. Okay, you still have the wall. And then you have an observer. Okay, this is observer. Okay, this is observer. So what happens in this case is now both of them, they are not moving. Okay, they are not moving. So in this case, what happens is actually now you have Vs equals to 0. Now your wall is acting as a source because it reflects the sound wave from the source. Okay, it reflects the wave from the source. So now we are treating the wall as a source in stage 2. And observer, the human is the observer right now. Source is the wall. Observer now wants to observe the frequency. So observer is also not moving. So you have VO is also equal to 0. Vs 0, VO 0. What is going to happen? So FO. Okay, FO is then equals to V. Okay, now we say plus minus V0 and also plus minus Vs, right? Fs. So now, when it comes to Doppler effect equation, if you have Vs that is not moving and also VO that is not moving, so you cancel out VO, you cancel out Vs. So you're left with F naught equals to V over V times Fs, which means F observer, okay, observed frequency is equals to the frequency of the sound. So the frequency received by the observer is then equals to 1133.33 Hertz. Alright? So kamu punya VO kosong, kamu punya VS pun kosong. So simplify the equations, you obtain FO equals to V over VFS. So dia beritahu Anda when you have a stationary observer and also stationary source, the source frequency and the observed frequency, they are equal. Okay, they are equal. So Fs equals to FO when your Vs equals to 0 and your VO is also equals to 0. Okay, when your Vs is equals to 0 and VO is also equals to 0. So when it comes to question C, okay, sometimes why students they cannot answer this question is because they don't think of it in terms of which one is observer and which one is a source. Okay, they cannot imagine the wall is acting as both in the same question. So stage 1, wall is acting as an observer because it's receiving sound wave from the source. But in the stage 2, it is acting as a source because it reflects the wave. Now the wave is coming from the wall. So when it comes to Doppler effect questions, the most important thing is to identify which one is acting as a source and which one is acting as an observer. Okay, so sometimes one object, one item, it can act as a both observer and the source at the same time. Depends on how the questions ask you. Okay, depends on the questions. Okay, so I think that marks the end of today's class. All right, so you just write down the solutions for these questions. Okay, so you have questions A, B, C. Write down the solutions. Write down the diagram. Then that's all for today's class. So if no questions, then you may leave the class.